Have you ever asked ChatGPT a question, and it confidently gave you an answer that was completely wrong? That happens because large language models don't actually know your private data. They only generate text based on patterns from their training. That's where Retrieval-Augmented Generation, or RAG, comes in. RAG connects a language model to your own knowledge base, so instead of guessing, it retrieves the right information and then generates an accurate response. In this video, I'll show you how to build a smarter AI assistant using Langflow, one that can pull real answers from your documents before responding. But before we dive into the demo, let's make sure we understand the key concepts behind RAG. We'll cover RAG itself, embeddings, vector stores, semantic search, retrievers, and corpus. These are the building blocks that make the whole system work. Let's start with RAG, which stands for Retrieval-Augmented Generation. Think of it as a way to make large language models, or LLMs, smarter and more accurate. By default, an LLM only knows what it learned during training. It doesn't have access to your private documents or up-to-date information. That's why it can sometimes make things up. RAG fixes this by combining two steps: retrieval and generation. First, when you ask a question, the system will retrieve the most relevant information from a database, often a vector store where your documents are stored as embeddings. Next, it augments your question by adding that retrieved information to the prompt. Finally, the model uses this enriched prompt to generate a response that's based on actual facts, not just what it remembers from training. In other words, RAG turns your language model into a search-powered assistant that always references your data before giving you an answer. Now let's talk about embeddings. Embeddings are a way for machines to understand meaning. They take complex data like text, images, or even video, and turn it into a list of numbers called a vector. These numbers capture the relationships and meaning behind the data. Here's the key idea. If two pieces of text mean similar things, their embeddings will be close together in this numeric space. If they're very different, their embeddings will be far apart. We typically use pre-trained embedding models like OpenAI's Text Embedding 3 Small, because training your own from scratch would require massive amounts of data and computing power. Pre-trained embeddings are accurate, ready to use, and they're what makes semantic search possible, letting us search by meaning, not just by exact words. Next, let's look at the vector store. A vector store is a special type of database designed to store and search data in a numeric form, rather than plain text. When we create embeddings of our documents, we get high-dimensional vectors, basically lists of numbers, and the vector store keeps all of those organized. The real power of a vector store is semantic search. Instead of only matching exact keywords, it finds results based on meaning. For example, if you search for automobile, it can also find documents that talk about cars, even if the word automobile never appears. Some popular vector stores are Chroma, Pinecone, Weaviate, and FAISS. In short, the vector store is the engine that makes fast and accurate meaning-based search possible for your AI system. Now let's break down semantic search. Semantic search is all about finding information based on meaning, not just exact words. Instead of only matching keywords, it looks at the context and intent behind a query. Here's how it works. Both your query and your documents are turned into embeddings, and the system compares their positions in this vector space to find the closest matches. This is essential for RAG because it ensures your AI retrieves the most relevant parts of your corpus, even if the question is phrased differently. For example, if you search for how to fix a vehicle engine, semantic search can still find content that says car motor repair, even though the exact words don't match. In other words, semantic search helps your AI understand what you mean, not just what you say. Next, let's talk about the retriever. A retriever is the part of your system that queries the vector store and pulls out the most relevant chunks of data for a user's question. Here's how it works. It takes your question and turns it into an embedding. It searches the vector store for similar embeddings. It then returns the top results, the most relevant documents or text snippets. You can think of the retriever as a librarian. When you ask a question, it quickly finds the most helpful books or documents from your library, so the language model has exactly what it needs to give a precise and accurate answer. Finally, let's look at the corpus. A corpus is simply the collection of documents or text data that you want your AI to use as a knowledge base. This could be anything from your company's internal documentation, PDFs and product manuals, research papers, or even a website's FAQ pages. In a RAG workflow, the corpus is first split into smaller chunks, then converted into embeddings and stored inside a vector store. When you ask a question, the retriever searches through this corpus to pull out the most relevant context, which the model then uses to answer accurately. Think of the corpus as your library of knowledge, the foundation of your entire RAG system. Here's a simple way to picture the whole process. The corpus is your library of knowledge. You convert all its text into embeddings, which are numbers that capture meaning. Those embeddings are stored in a vector store, which acts like a searchable catalog. A retriever looks through this catalog to find the most relevant passages. Finally, the LLM uses that data to generate an accurate answer. That's the entire idea behind retrieval-augmented generation, connecting a language model to your own data so it answers with facts, not guesses.
Hey guys, now that we understand the concept of RAG, let's build it step by step in Langflow, all from scratch. The first one is to create a new project. This is the project. Now, give it a name, RAG. Create a new flow, blank one, then call it RAG. Now, as we said in our explanation, one of the most important things we need will be our knowledge base. You can use anything for this. You can use AI, APIs, anything to get your knowledge base, and then you pass it to the vector store. So we are going to use a file-based knowledge base. So all you just need to do is upload a file, upload some files. You can upload multiple files, and they will serve as your knowledge base. So now let's turn our file to a text. This will be a list of text. As you can see here, this is going to be a list of text. The chunks will be 1,000, so we have each 1, 2, 3 to thousands of chunks. Chunk overlap also is the number of characters to overlap between chunks, the number of data in your chunks, all those type of things. Yeah. Now the next thing we're going to need will be our vector store. This FAISS, FAISS, is both a vector store and also a retriever. Remember we talked about retriever. So put it into the ingest data. So we give it our data. And one of the most important things we need will be embeddings. So one, you can use the OpenAI embedding. You can see this here. If you have it's open, if you have OpenAI key, I will use something free, Mistral. So this is Mistral embedding. So with this key, let's move forward. Paste the API key or save it as a global variable. Connect it to the embedding. Sorry. Yep. Then the next one, you can change this. Let's call it RAG. So you can have a fresh data for this dude. That's it. The next thing is we need our search query, and this is what we're going to search for in our database, and that's definitely the chat input or the user input. So this chat input is what your user is going to type into, and that's what you're going to search for in your database or in your vector store. So the next thing we'll be needing will be a parser, and this is to pass these search results. Let's use a data frame. It is going to pass it into a text. You can see here, pass it to the parser, leave this template as it is, and it's going to pass it into list of text. If you are, this file is going to get you some list of, we said we are storing list of vectors. So the chat input, the search will get you the list of similar vectors or similar list of text or similar list of numbers, if you understand what I mean. So now you have this. The next thing you will need will be your prompt template. Now put it here. You need some type of template. I have a template I've used before, so I'll just copy that. Yep. Edit this and put in here. We'll put this later, but let's copy it out for now. Now not saving. Check and save. Then you can now connect this past text into this context here. Let's review our template. This is the context. That's what we get and passed from our retriever. Then we tell the AI based on the context above, provide the most accurate and helpful answer. Role: you are a RAG agent. Objective: answer the question clearly and when relevant, provide additional guidelines or insight to support the user. That is, when the user asks a question, if the AI has more context or more guidelines, it can add it into the answer it is going to give. Now we have a prompt template. The next thing we need is an LLM. You can use a local one or anyone you prefer. Let's use the Google generative one. Google generative AI. This. You can use OpenAI, anything you love. Then pass the prompt to the system message and come back here. The chat input, pass it. Okay, the chat input, pass it here. The chat of the user, pass it as an input here. As you can see, we are moving. Then the next thing we need will be the chat output to output the LLM or the output of our agents. So this is where the user see what the agent responds with. So the model response should be passed into that. And now all we need to do, and this is it all. We've built a RAG agent. All you need to do is add more capability and tools to the agent. With this, you build a RAG agent. Now let's test this out. Let's provide a file, add a file called understanding climate change. Let's put it here. Let's go to the playground. Let's ask the AI what is climate change. After a while, the agent provides us a response. We're using the most simplest Gemini version or model. As you can see, all of these are related to what we give there. This is the file here, and you will notice it is based on this context. It is giving us a response. So that's it. We have a RAG agent, and if you want, you can change this text instead of using a file. Bring in your API model to get your data from another web or from another REST API and pass it into the files, and then and then it gets working. The another thing you can do is give this a persistent directory, so you don't have to run your vector store every time. Now let's ask a new question. Now, after a while, we get an answer. Now, let's check it. See, a very long one of that. Based on the provide, here are some best practice for addressing climate change, categorized for clarity. Global cooperation, interdisciplinary approach, citizen engagement, positive mindset. The next thing I would love to add is message history. So your AI can have idea of what you've been talking about and where you're at. Now, let's do this. The first one will be for stop. And then we can give it the, let's do it this way. We give it the AI output. So we store the AI outputs, and then that's it. Yes. Now, in our prompt, we should give, you remember, we deleted something, so we are going to add it back. Come in, let's copy it real quick again. So, yeah, we need to edit this, paste it, and the only thing we're adding is the previous conversation. That's it. The previous conversation between the user and the AI, and that's it. And that's all we need to add. That way, the AI will have more context and have everything you've been chatting with the AI. Let's go back here and say, so this is going to run. After a while, now we have a response. The primary causes of these burning fossil and all, it is important to note. As you can see, this is getting it all from our data. And this only takes us 5 minutes or 5 minutes of our time to build. Very easy and straightforward with Langflow.
Thanks for watching. If you enjoyed this video, hit like and subscribe. Check out my other tutorials, and see you in the next one.